Okay, so mass, weight, and gravity, lots of things that get mixed up and interchanged. Mass and weight aren't the same thing. Really important to know. Mass is how much stuff there is in something. Weight is a force that pulls you towards the Earth. Okay, and that weight force is due to gravity. Okay. Now, another important thing here is an object has the same mass wherever it is. Okay, if I have a bowling ball that weighs 5 kilograms, it has the same mass on Earth as it does on the Moon, as it does on Jupiter, okay, as it does outside the solar system. Its mass is the same everywhere, okay, because the mass is just about how much stuff there is in it, okay, and that hasn't changed. However, the weight does change. Weight, I'll just label all these. So this is the weight, and this is the equation linking the three together. The weight is the mass times by g, which is the acceleration due to gravity. Okay, so g is how fast you accelerate towards the Earth due to gravity. So if you jumped out of a plane, it's how fast you accelerate towards the Earth due to gravity. A bit of a caveat here, which is this only works if there's no air resistance. In reality, you start to reach a maximum velocity. You might have talked about terminal velocity in physics before. So this only works for a bit before air resistance kind of ruins it. But to work out the mass, to work out the weight, we do the mass times this acceleration due to gravity. This is not a force, okay? It has units of meters per second squared, so it's an acceleration. Okay, not a force. The force due to gravity is weight, effectively. Okay, so a little bit confusing, but it is an acceleration. On Earth, g is about 9.81 meters per second squared. In exams, you will normally use g equals 9.8. Okay, that's normally the value you'll use. That should be given to you on the exam paper, by the way. On the front of the exam paper, it'll say take g equals 9.8 meters per second, unless otherwise specified in the question. Okay, so that's normally the value we'll take. It's important to realize, though, that that isn't constant everywhere. On Earth, g is about 9.81 meters per second squared. That's on the surface of the Earth. On a plane, it actually gets a little bit lower. It gets a little bit lower, so it goes down to 9.77 meters per second squared. So it's only a small difference, but the reason is because we're further away from the center of the Earth. The further you go up, as in the higher your altitude above the Earth, g gets smaller and smaller as you get further away from the Earth. So if you go up to the level where satellites are, gravity is considerably weaker than on the surface of the Earth. Now, often this is a practical thing to use, right? Most of the things we're considering are on the surface of the Earth, so it's a good value to use. It's just important to realize that g isn't the same everywhere, and therefore your weight isn't the same everywhere, because look at this formula. Your mass stays the same, but g changes. The higher up we go, g gets lower and lower, so also your weight gets lower and lower. So on the Moon, for instance, g is much smaller. G is only about a sixth of what it is on Earth. So your weight is considerably lower. Your mass is the same. So if you go to the Moon and you have a mass of 80 kilograms, your weight used to be about 800 newtons, but it'll be between 100 and 200 newtons when you're on the Moon, considerably lower. So your weight on Earth, if you weigh 100 kilograms, would be 981 newtons. Here's a quick example to look at. But your weight on a plane is only 977 newtons. So if you weighed yourself on a plane, you would find it's very slightly lower, okay? Because you're slightly further above the center of the Earth.